Good afternoon, ladies and gentlemen of Precalculus. We are going to finish up on this exercise here, and one reason that I wanted to get to this particular problem today is that this is one of the types of problems that's going to be on your test in a couple weeks. So I want to make sure you have some exposure to it. Actually, the one on your test is going to be, in reality, easier than this. Why do you think the one on the test is going to be easier than this?
Because you want to be nice.
Not that I want to be nice.
Because we can look at our paper and it's going to be the exact same thing.
No, it won't be the exact same thing. It'll be the same formula, but it'll be easier because the way the way that you can plug in to find an answer. This one here requires you to actually find two answers, and so this is going to be a little bit of an involved process the way we do it today with this. But you'll see. I hope it makes sense to you because it'll kind of tie into what we've done. So basically you have your formula here, and your cup of coffee is cooled from 92 degrees to 50 degrees after 12 minutes. And so what you do is you're going to use these, it's just figuring out what to plug in to the formula. And so you have a room temperature of 22 degrees, and that's going to be T sub m. And so any place you see T sub m, you're going to replace with 22. You see that? And then your starting temperature is T sub 0, so 92 is going to go right here. And so we have that, and we know that the thing is going to cool to 50 degrees after that much time, and then it's going to be times E to the negative K, which is constant of cooling, times T, which is 12 minutes. And so what you have is an equation that you solve for K, your constant of cooling. And then once you have your constant of cooling, you can use this formula to find out how long that cup of coffee will take to cool to 30 degrees Celsius. Newton's law of cooling, one of the things invented by Newton. This is one of the things that anybody take forensics class here? You are taking it? Are you taking it now? Well, you got to tell Mr. Wiley, just tell him about Newton's law. We worked on Newton's law of cooling. It might impress him. Maybe you get some extra credit out of him that way. I don't know. But what's happening is you can imagine that if you have somebody who dies, how long did it take? Well, based on the room temperature. And what's that?
We've talked about that, but we didn't call it the Newton's law of cooling. There's like three different names.
So you've talked about it, and you haven't used it yet? Have you used it? Well, we're actually doing it here today, but with a cup of coffee. And then this one thing, is that the kind of coffee that you like?
I drink my coffee cold.
Oh, the cold coffee, okay.
Frappuccino.
Okay.
Just like a black coffee.
I feel like
You can't do that.
Just blend up almost like room temperature or cold.
Okay, all right. I'm not a connoisseur of coffee myself. Hot chocolate I'll have occasionally. All right, so let's go ahead and work this out. So if we subtract 22, we get 28 is equal to, and that's going to reduce to 70 e to the negative k, I'll say negative 12k. So are you okay with this so far?
What's the value of k?
That's what we're trying to find out, Will.
So we're gonna solve what k is, and then we divide by 70, right?
Where do we get 70?
And so we have e to the power of negative 12k is equal to 28/70ths. Okay, how are you going to solve for k we got to this point? How do you solve for k now?
It's 1 over
Okay, this is going to be, remember this log base E.
Yeah. Oh, that's right.
So log base E of 28/70 is equal to negative 12K. And so I'm gonna take this, I'm gonna sort of work backwards from the way I usually do. I'm gonna work back up here. Do you see that? So what we're gonna do is we're gonna say E, well actually we've already done that, right? So what K is gonna be equal to all this, but I'm gonna change this to ln, right? That's what ln is. So 28/70 over negative 12. And then you're going to have what K is. All right? So let's find out what that is. And I might have done this from 5th period, I'm not sure. Yeah, okay. Here it is from 5th period. You see that?
Yes.
So 0.07636, something like that. 0.07636. And once you have that, now we can find out how long it takes to cool to 30 degrees. Well, to do that, we take our original equation. And I'm gonna show you how to solve by graphing too, that you might like. We'll see, or convince you. So now we want to find out how long it takes to cool to 30 degrees. So our final temperature 30 is equal to our temperature of our medium, which is 22 degrees. Plus we have 92 minus 22, that's going to be the same, 70, e to the negative, and we have what K is now, don't we?
Yeah.
0.07636 times T. And we can subtract 22. So we get 8 is equal to 70 e to the negative 0.07636 T. All right, what I'm going to do is I'm going to solve by graphing. And how would you solve this by graphing?
Plug in the numbers and just put
Pardon me?
ST.
Plug in the numbers? Yeah, okay. Now Kaylee just said plug in the numbers. Now it so happens you don't have any numbers, but on a multiple choice test, you will have a number you can plug in, right? So you don't have that now. And so what you say is a good suggestion, just that we don't have the data for what I think you're trying to suggest right now.
No, that's
That's not what you're suggesting right now? Okay. What I'm going to do is I'm going to go to graph, solve by graphing, and for that we're going to subtract 8 from both sides. Does this look familiar from yesterday? Yeah. So we get 0 equals this minus 8, and we just look for where the thing crosses the x-axis, and we'll have our answer. So let's get here. Let's get here. Okay.
Happy Thanksgiving.
Okay, great. Thank you so much. See, I've had some FFA officers who come by to wish me a happy Thanksgiving. Isn't that nice?
So very nice.
Yes.
I love FFA.
Okay, so now we come here. So I'm going to clear this out. So we have, what is it, 70
70
e
to the negative.
to the power of negative point
0.07636
x and minus 8.
Yes.
And what we're going to do is come to the, so I have the window set up. I'll show you what the window is. The window I have is this. And then when you graph, what do you see? You see an x-intercept, right? So how do you find your x-intercept? Second, trace, 0,
2.
which is 2, thank you. And you're given a left bound of 15, so I'm going to arrow closer, and once I can see this over here, I'm going to press enter, and then when it says question right bound, and just go to the other side and press enter twice. And so now you know how much time it takes. How much time is it going to take?
28.405623.
Yeah, so 28.41 minutes, right? So 28.41 minutes. So T equals 28.41 minutes. All right, what I want you to do is go look at number 50 and try to replicate the same process with number 50. And what I'm going to do for you after minute 2 is I'm going to give you what the answer is so you can sort of check your work as you go. Can you do that?
Yep.
All right, everybody good with that? Kinsey, you're good with this? Sure. She says with a lot of conviction. Appreciate that.
Mr. Dickey, this?
Yeah, be happy to. Okay. Let me see what's going on here. Okay. All right, what I want to do for number 50 is I want to put down the answer here so you can kind of check your work based on, just to see if that's what you got. Does anybody have an answer yet for this, number 50? Did you like solving by graphing better than you did by taking the logarithm? No? Non-committal, that's fine. You don't need to commit. You guys are too busy working.
How do you put LN in a calculator?
ln, ln, it's right here,
I see.
ln. So just check your answer. Has anybody got to the answer yet? from this?
Almost.
Just about. What you're going to find on your test Wednesday after next is you're going to have a Newton's law of cooling problem, but it's going to be a lot easier than this. Because you're not going to have to find a constant and go back and use the constant and all that. Did you get an answer yet on this?
I'm at the point, but it's not graphing.
It's not graphing?
Mr. G, will you come check mine, please? So I should listen to you. Oh, never mind, thank you.
This answer up here?
Yeah.
Answer up there. Is that what you got?
Yeah.
Okay. It might be a decimal point or something off, but that came straight from the book.
What'd you get on the bottom one? 0 equal? I got 260.
Are you finished there? Good. Okay, good. Yeah, I'll pick up your paper a little later.
Yeah, I got 260 right there. They're watching The Grinch in there.
Oh, are they?
Yeah.
Next door? The Grinch?
I watched it last night.
Oh, you did? Okay.
Pretty sure it is. Over here, we used the other one. We used the bottom. That's the last one. That's the last one.
So that's as far as you got? Oh, really?
Stay away from us.
I got some muscles.
Didn't work? Last week.
I think it's
Some my neck muscles.
Okay, what you have to do is you just subtract out the 45. So put it aside.
Maybe like sleep time.
I guess so.
Someone told me I was laughing
Okay,
while I was asleep.
I'll do it here.
Sleep time.
So on this one one, what did you get for your K?
0.08226.
0.08226, okay, I'll show you.
Anyone know anything about that?
So if you have K equals 0.08226, then you can use this equation here. You want to find out how long it takes to cool to 90 degrees. So here 90 is equal to your temperature of your medium, which is 65, plus I sub 0, T sub 0, which is 350, minus 65, e to the negative 0.08228 t, 226 like this, 226, okay? So now what you can do is you can subtract 90 like this from both sides and go to your calculator. So that's going to be, what is that going to be, 285? So we get we get 65 plus 285 e to the power of negative 0.08226, is that what you said? X, and then you subtract out 90, right? Is that what you got? So now our window, I think, should be good for what we need. So we press graph, we should see the thing hit, which we do. And then if you go to second trace, 0, it says left bound 15, so I'm going to have to scroll over to the right some. There it is. Press enter, and then I'm going to go to the right, press enter twice. So there it is. Okay. Did you figure it out, Kaylee? What you did? What about you? How are you on this? You did okay? Anybody not okay on this? Kenzie, you okay? Carmen, you okay?
Carmen's fine.
Carmen's fine? Jane, everybody? Okay, good. Okay, one thing we worked on yesterday a little bit was the sound intensity. And I don't want to do all this exercise today because there are 6. There are 2 sides of the paper. So I just want to kind of briefly go over maybe just maybe 3 problems or so from this.
We did number 48.
48?
No, we didn't do that.
We didn't do 48 yesterday? Yeah, don't worry about that. I'm not worried about it. I'm trying to keep up right. So here's the basic formula, and we talked about that yesterday, didn't we? So we're going to kind of go into a little more detail. And here's a chart, and the main things that are helpful to know are these 2 things. This is the one that Will was talking about yesterday.
Yep.
And then another thing that's helpful to know is this one right here, this threshold of pain. And we talked about that yesterday too, didn't we? This is when you walk right by that fire alarm and your ear hurts when you're that close to it, right?
Yeah.
That's 120 decibels. Thereabouts, of course. Every human being is a little bit different, of course.
Yeah.
But generally that's what it is. And really, if you have continuous exposure to sounds above 100 decibels, okay, that's going to be cumulative hearing damage, essentially. So we try to be careful about that. Most of the below 100 decibels, busy traffic, that's not going to hurt your ears long term, is it? I mean, I guess it can depend on what it is. But So we go to the problems here. A fire alarm sounds with intensity of 1 watt per meter squared. What is that sound intensity of decibels? Yeah. Yes, so what is your sound intensity going to be? So your decibels are equal to 10 log I over I sub 0, and I sub 0 is defined to be 10 to the negative 12 watts per meter squared. And so you can just plug in values here. If you want your decibels for this 1 watt per meter squared, you have 10 log of I, which is 1, over 10 to the negative 12 power, and you plug this into your calculator, you will have your answer. 120? That's what you got, 120? Okay, good. You still get 120? Now the good thing about these types of logarithms is these are really pretty realistic to do without a calculator, many of them like this one, because 1 is 10 to what power?
The 0.
10 to, so this is going to be 10 to the 0 power over 10 to the negative 12 power. What's 10 to the 0 divided by 10 to the negative 12?
10 to the 12.
10 to the 12. So we have 10 log base 10 of 10 to the 12th power. What can we do with that 12?
Do the switcher move?
Well, you can move that 12 out front, 12 times 10, so that's going to be 120 log base 10 of 10. And what's log base 10 of 10? 1. So you have 120 decibels that way. All right. Questions about that?
Yep.
I want you to go ahead and look at problem 3, which is very similar. And yeah, go ahead. Do problems 3 and 4. Problems 3 and 4 really quickly. And I just want to do those today. They're going to be pretty much as easy as number 1.
So we don't do number 2?
Yeah, don't worry about 2, and especially don't worry about 6. Just, and then that's going to be pretty much like the instruction part of class today. But I do want to talk to you about. I want to give you a formula chart to look at and talk to you about what I want to give you.
I don't know what it is, I think your mom, this is the money, and there was something to do with that. It's like, it's not as bad, but like, now it's just like yours right here. Oh, we were just going to show you.
If he's done.
Maybe. Where do you just go back to it? I'm gonna go through that. I'm about to pee myself.
So what did you get for your jet engine in decibels?
130.
130, okay? Should be 130.
Wait, how do you figure that out?
Well, what you do is you take your equation. Your equation is going to be your decibels. It's going to be equal to 10 log of I over I sub 0. And if you substitute in 10 for this,
I just didn't know where to substitute in that.
and if you substitute in 10 to the negative 12 power for this, you're going to end up getting 130.
Okay.
Okay? And then for number 4, let me guess. Number 4 is going to be, let me see, 2 times. Now 1 would be 100 decibels, but 2 would be a little bit higher than that. So it's going to be 3. It's going to be 103 decibels,
Yep.
roughly.
That's 103.010.
Okay, so that was just an estimate. That was just my estimate, just because I knew that 10 to the negative 2 watts per meter squared, that is going to be exactly 100. And then when you multiply that by 2, it's going to raise it up to about 3 other extra decibels. So anyway, so that's really all I want you to look at on this one today.
So we can put it in.
Yeah, you'll turn it in.
What is the answer for number 4?
Should be about 103 decibels. Yeah, okay. Now, see, that's one that you, since it's not it's not 10 to the power something, you have to use a calculator for that one. Now, 1 and 3 you should be able to do without a calculator pretty easily, but 4 not as much, except that you estimate like I did. Okay, I want you to hold on to your ACP formula chart, and I'm going to talk about that a little bit. And then one other thing.
Well, I had it on, probably when I realized in the hallway that it was like, I had it in the hallway, and then I ended up, I'll tell you what. So when I look at that,
Great, thank you.
so we have that one.
Okay, this, I want to talk briefly about the formula chart, and this is it. This is what's going to be available to you in part. And I want you to go to exponential functions right here. You see where it says exponential functions? Do you see anything that looks any way remotely similar to what we've done in this class?
Yes.
You do, right? This one probably most,
Yep.
right? Now, the thing that we're going to talk about on Monday after you get back, we're going to talk about these 2 equations right here,
Yeah.
compounding interest and continuous. I also want you to write down on your formula chart this formula right here next to it somewhere. Can you write that on the margin? A equals A sub 0 times 1/2 to the power of T over HL. Do you recognize what this formula is?
Is it halfway?
It's a half-life formula. Thank you. I'll find a paper to put a sticker on it somewhere for you. Yeah,
What's
this
that? T over what?
T over HL, and HL standing for half-life. So that's one thing that you'll be able to see. And then we're gonna do these types of problems on Monday after you get back a little bit, and maybe on Tuesday also, but especially on Monday is going to be what we're concentrate on. And I want to show you something else on this chart. Most of this chart we're not going to use first semester that much. Now typically, I mean, point slope and standard, all this stuff, that's like standard on about all formula charts, right? But these ones right here, we're going to hit these after your test. And these might look kind of intimidating, these one sequences and series, and also permutations and combinations. And so that's where we're going in this semester after this for a couple weeks. Now, the last thing I want to give you is this. I want to give you some problems to work out over the break. And these problems here are review of material we've covered in the class before chapter 3.
Your instructions have this done when we come back.
Okay, you need to let me finish. You need to let me finish my thought.
I wasn't here.
Yeah, I don't want you to be, you finished with this? So, here, you finished with it?
You're smelling. Who's home? Whose house? Oh, is it your hands?
Okay,
You get one.
now, I want to tell you how this packet is arranged. Okay, the packet is arranged in problems 1 through 12, I think it is. And there's 1, and there's 2, and then there's 3A, 4, 3B, 4A, 4B, and so on. All right, what I'm going to do is probably after school is dismissed, I'm going to make a video that's going to review problems 1, 2, 3A, 4A, 5A, 6A, 7A, 8A, 9A, 10A, 11A, and 12A. So that's all going to be on video that I plan to send out probably maybe tomorrow, something like that. And so you can look at those, so you have exposure to that particular problem. And where did I get those problems from?
The test.
I got them from the test. So I worked backwards from the test, what is tested. And so you're going to be able to find, and then what you're going to do, if you have questions and you try to work out problem B or have questions, what can you do over the break?
Nothing.
You can do nothing, or you can
Email you.
You can email me, and I'm going to shortly give you my email address so that you can do that. And some of you have already been in touch with me that way.